All right, 1-3 is all about angles. We're going to be measuring and constructing angles. Well, we're not really going to be constructing, sorry. So by the end of this video, hopefully you can name and classify angles. We're going to be talking about angle bisectors, but we won't be constructing until later on in class. But I promise we'll get to it. There's like 5 parts to these notes. We're going to first define an angle, and this is the symbol for angle, like a slanted L. Then we're going to talk about measuring angles, and we're going to skip that and do it in class, how to use a protractor to measure angles. Then we're going to talk about classifying, and again, some of you guys probably are familiar with how to classify angles already, but what you probably aren't familiar with is something called the Angle Addition Postulate. So that's the 4th thing we're going to talk about, and then finally we're going to talk about angle bisectors. So those are the 5 main parts to this video. There's a lot of vocabulary, so make sure you come back and you have a complete understanding of all of these terms. So let's talk about an angle. An angle, you guys have heard about this before, it's formed by 2 rays. Remember, a ray is something that has one endpoint and then goes on forever and ever and ever and always. And when they have a common endpoint, sometimes they can make an opposite ray, but in this case, this would make an angle. So this common endpoint is called the vertex. Let's see, what else do you need to know? If you're talking about everything inside, this is all called the interior of an angle. If you're talking about all this space outside of it, that's going to be called the exterior of an angle. Let's see, there's lots of ways you can name an angle. So for example, let's say I gave this vertex here an E, and then let's say there's a point on this ray B, and there's another point over here D. And then, okay, so since this is a simplistic angle, you could go ahead and just call it angle E. That's fine. But guess what? In geometry, they're not going to be this simple all the time, so you probably won't be able to name angles like that. Rather, you'll probably have to use all 3 letters. So since E is the vertex, it has to go in the middle. So since you're talking about all this space in between, it's from B to E to D. So angle bed is one way to do it. You could also do D to E to B. So these all are talking about this lovely yellow space. Other times, and again, not very often, sometimes they'll put little numbers in here, like number 1, because this is the number 1 angle. It's important that it doesn't have a degrees. That's measuring the angle. If it has a degrees, you can't do this. If it just has a little number right there, you can go ahead and just call it angle 1. Okay, and again, you probably won't be using these very often, but if you can, then go for it. Finally, what was I going to say? Oh yeah, okay, so mostly they're going to be simplistic like this. You're going to start seeing angles a little bit more complex, like, okay, here's another one you'll see very shortly. Something like this, a big fat X, right? Let's say this center is called, we'll go C for center, and then let's just go A, B over here, D, and E. Let's say I only wanted to talk about this section right here. Okay, you could not just say angle C. Angle C does not tell me which part you want to talk about, so that is not an okay way. Rather, a better way to do it would be angle B, C, D. There's one other way you can name this angle. Go ahead and see if you can figure out what that is. Okay, moving on. Again, we're going to be talking about how to measure angles later. Let's go ahead and call this number 1 in your notes. Number 1. Write the different ways you can name the angles in the diagram. Hopefully you can see this. Let's see. I can count 1, 2, 3, 4, 5, 6 different ways. I'll get you started. The easier ones are angle 1 and angle 2. Sweet. Okay, let's see a more complicated way. Let's talk about, if we wanted to talk about this angle, what would that be called? It would be angle QTR. And then, or RTQ. Go ahead and see if you can name the yellow angle. And then I want you to go ahead and see if you can name the entire angle. And we can call all this number 1 on your notes. Okay. So the 3rd thing we're going to talk about is how to classify angles. Again, some of you guys have probably already heard this and seen this, and some of you guys know how to do this, the angle aerobics. We can do that in class. Woo! Angle aerobics! Remind me, because I'm probably going to forget, and it's going to be super fun. Angle aerobics. Acute angles are acute little angles. They are less than 90 degrees. They're from 0 to 90 degrees. We're not going to talk about anything less than 0 degrees in this class. That's Algebra 2 and pre-calc. Exactly 90 degrees is called a right angle. Something that is bigger than 90 degrees, but less than 180 degrees. Again, we don't talk about anything larger than 180 degrees in geometry. That's called obtuse. And if it's exactly 180 degrees, it's called a straight angle. It also is called a line. It's important. That's important for later on in this class. Okay, so those are all the definitions. Again, we'll do protractors later. Third thing I want to talk about are, another thing, vocab word you need to talk about is congruent angles. Congruent, again, means that they're exactly the same size, and this is the symbol for congruent. So since we're talking about angles, we're saying that that's a thing. That's why you use the word congruent and not equals. So if I wanted to talk about this angle and this angle, I would say that angle ABC is congruent to angle DEF. Now let's say I wanted to talk about the numbers. Let's say this angle is 20 degrees because we measure our angles in degrees. And let's say this one is also 20 degrees. If I wanted to talk about the numbers, then I could say that the measure of angle ABC is equal to the measure of angle DEF. So whenever you see this M, we're talking about numbers, we're talking about how big that angle is, and we're saying that it's equal. So we use equal when we're talking about numbers, congruent when we're actually talking about the angles. I know that that seems really silly. Just like when we were talking about segments, if I wanted to say that this segment is congruent to this segment, we would use tick marks. We also have tick marks for angles, and that's what these red arc marks are. I just call them tick marks again. You could go like this if you wanted to. Let's say I wanted to talk about some other angles, and I want to say that this angle over here is congruent to this angle over here, but they're not congruent to these two angles, then we would just use 2 tick marks. All right, so very similar to what we did yesterday. Also very similar to what we did yesterday was the angle addition postulate. We're going to use these in proofs, and I abbreviate like this, angle addition postulate. So you're more than welcome to abbreviate like that if you want to. Now, angle addition postulate, just like segment addition postulate. If I tell you that this blue part is 20 degrees and I tell you that this red part is 10 degrees, how big would this whole angle be? It would be 30 degrees. And that's what this says over here. Okay, if you take 2 parts and add them up, you're going to get the whole thing. So let's try that. Let's title this, I think it's we're on number 2, right? Yeah, so let's call this number 2 in our notes. They're going to give you pictures sometimes, which is nice of them because I don't always, and you're going to fill in what you know. So measure of angle DEG, DEG, that's this entire angle. So DEG, this whole thing is 115 degrees. I want you to get used to drawing in your pictures if you can as much as possible. And then it says measure of angle DEF is 48 degrees. So this part is 48 degrees. And I want to know what a measure of angle FEG is. So what is the rest of this? Well, are we going to add or are we going to subtract? Well, of course, we're going to subtract. So then the answer is going to be that it equals 67 degrees. Boom, done. For number 2, that's the answer. All right, so that's how can I make, what I want you guys to think about is how can I make this harder? Because that was a pretty simple question. One way I can make this harder is instead of numbers, I can give you algebraic expressions. So for example, let's say I said that DEF is 2x and that FEG is 4x. And sometimes they'll go like this, 4x degrees, 2x, and they'll put it in parentheses so that they know you're talking about degrees. And that this whole angle is 60 degrees. And then I want to know what is the measure of angle DEF. Go ahead and see if you can answer that one. Make it again part of 2. We'll call this 2A and we'll call this 2B. So go ahead and see if you can figure out what measure of angle DEF is. That's one way I can make it harder. All right, so last thing we're going to talk about are angle bisectors. We learned this word yesterday. Bisector means to cut it in half, right? So an angle bisector, you can think of it as like the midpoint. It's like yesterday when we were talking about a midpoint or a segment bisector. So it's going to cut something exactly in the middle. So if I wanted to tell you that JK is the bisector of this angle, I could do that by putting in those tick marks. So these tick marks show you that this is exactly the middle and it's the angle bisector. So then, like you said, if this is the angle bisector, then that means that angle LJK is going to be congruent to angle KJM. So what we're going to do is we're going to give you problems like this, and you guys are lucky. I'm going to delete this. Just from this, you can draw that picture I just deleted. Let me show you how. It says ray KM bisects this angle. We're going to start by drawing that angle. J, and I'm really boring, I'm sorry, I always draw my angles like this. You don't have to. So J, K has to be the vertex, L. And it says ray KM bisects it. Well, here's K already, so that means M is going to be over here somewhere. Beautiful. And since it's bisects, that means we're going to put in those tick marks. Bam! All right, now we're going to fill in what we know. Measure of angle JKM, that's this part right here, is 4x plus 6 degrees. See how they use those parentheses? That's just because they're talking about degrees. And measure of angle MKL, MKL is 7x minus 12. Go ahead and find JKM, and I want you to highlight this. Remember, the most common mistakes is students just solve for x and then they're done. No, go back and read the question one more time. So all you're going to do for this one, since it's a bisector, that means that this piece is going to equal this piece. So you're going to just do 4x plus 6 equals 7x minus 12. I think this is number 3. Sorry, guys. And then go ahead and solve for x. Once you have x, go ahead back and plug it in to whatever it is that they plug in. Yes, to whatever it is that they want. And that is all of the notes that we're going to talk about today. Go ahead and remember, make sure you have an understanding of all of these vocabulary words. You rock.